So we have a cup of coffee that has a temperature of 95 degrees centigrade, and it takes 30 minutes to cool to 61 degrees centigrade in a room with a temperature of 20 degrees. And using Newton's law of cooling, which is given by this equation for this situation, A, we're going to find the value of K, and B, we're going to find the average temperature during the first half hour. Okay, so to start with, we know T is time in minutes. So when T is 0, everybody, what is T of 0? So T of 0 is 95, and we know that's true because T of 0 is 20 plus 75 e to the 0, which is 20 plus 75 times 1, which is 95 degrees. So to get K, we know that T of 30 minutes is 61 degrees. So we're going to substitute T being 30, and that's going to allow us to get K. So we can say that T of 30 is 20 plus 75 e to the negative k times 30, which is negative 30k, and that we know is 61 degrees. So first we are going to subtract 20 from both sides, and we get 75 e to the negative 30k equals 61 minus 20 is 41. So now we're going to divide both sides by 75, and we get that e to the negative 30k is 41 over 75. So now we take the natural log of both sides, and we know that log and e undo each other. So we get negative 30k is the natural log of 41 divided by 75. So now we divide by negative 30, and that gives us that the exact answer is K is log 41 divided by 75 divided by negative 30. Okay, so the book wants us to use decimals, so this is 0.02013. Okay, so now we have the value for K, and we're going to go back to the original equation, and we're going to put that value for K in that equation. So I'm going to write the equation now with K replaced with 0.02013. So I now have that T of T is 20 plus 75 e to the negative 0.2013t. And this is the formula that tells us how the temperature of the coffee is changing time t. Now part B is we have to get the average temperature. So we would say, and it's the average temperature over the first half hour. So that means we want T between 0 and 30 minutes. So we get T average is 1 over 30 minus 0, the integral of 0 to 30, 20 plus 75 e to the negative 0.2013t dt. And this is going to be the average temperature. So we're going to work this definite integral. I'm going to work it on the next page. So we have that T average is 1/30th, the integral from 0 to 30, 20 plus 75 e to the negative 0.2013t dt. So I'm going to separate this. So T average is 1/30th. I'm going to do the first part, 0 to 30, 20 dt, and then it's 1/30th, the integral from 0 to 30, 75 e to the negative 0.2013t dt. And this second integral is going to require a u substitution. So I'm going to do this one first with u substitution. So u will have to be negative 0.02013t. So du divided by negative 0.2013 is dt. So this integral just becomes, I'm going to move the 75 over 30, the integral of e to the negative, well, I'm going to make it u, it's because I already have the negative, divided by negative 0.02013 du. So this answer will be 75 divided by 30 times negative 0.2013 e to the u. So working this out, I have that t average is 1/30th. The antiderivative of 20t is 20, of 20 dt is 20t from 0 to 30. And now I have to do this one, but we already kind of know what that answer is going to be. So now using what I have here, this would be 75 divided by 30 times negative 0.2013 e to the u, but u is this, so it's e to the negative 0.2013t from 0 to 30. And of course, at that point, we now have to use our calculator to help us with this. Okay, so what we have, everyone, is 1/30th of 20 times 30 minus 0, plus I did all of this and I got negative 124.1927, etc., times e to the negative 0.02013 times 30 minus 1. And this, of course, worked out nicely. We have 20 plus negative 124.1927 times 0.46675 minus 1. And so this becomes, you guys, 20 plus, because you have the minus a minus, 56.2996, which really is 76.3. So we round to one decimal. So there's 76.3 degrees is the average temperature. So it's T average. Here's it. Sometimes for part C, I will say tell when the temperature of coffee is exactly the average, the T average. So to do this, we are going to have to set the equation, which was 20 plus 75 e to the negative 0.02013t equal to 76.3. So now we subtract 20, and we get 75 e to the negative 0.2013t is 56.3. Now we will divide by 75. which gives e to the negative 0.02013t is 56.3 over 75. Now, of course, the last step, natural log of both sides, and we get negative 0.02013t is log of 56.3 divided by 75. And now we divide by negative 0.2013. And we get, I don't have enough room here, t is approximately 14.24 minutes after. Yeah. Great. Okay.